Hey guys, in this session we're going to be looking at the geometric reasoning paper, the level 1 from 2015. Okay, let's get started. Okay, so the best way to do these or watch this video is just pause when the question starts so you can read through the question and then follow my answers. So yeah, it's probably the best way to do this. So in this question, they're asking you to find the size of the angle BCF. Now BCF is basically this angle here we're looking at. So we got to have a look at some of the clues here. Now the first clue is the fact that the rack is symmetrical around the line CL, which means that part there is symmetrical. Well, anything to the right side of the yellow line is symmetrical to everything on the left-hand side of the yellow line, which means we can say that this angle here, well, because it's symmetrical, that these two angles here are going to be like 90 degrees. And because of that, angle BCL is actually going to equal 90 degrees. I'll show you guys where BCL is. So BCL is this part here. All right, so that's BCL, and BCL is 90 degrees. Now we're trying to figure out what BCF is. So that's this part here, BCF. And we know that this angle here is 24 degrees. So then what we can say is we can say that angle BCF equals 90 degrees minus 24 degrees, which means angle BCF is equal to 66 degrees. Now in terms of reasoning here, you could say that this is because angle BCL, not BCL, sorry, yep, no, not BCL. You could say that the reason is because angle BCF and angle FCL are complementary angles. And complementary angles add up to 90 degrees. So that's one reason you could give. The other reason you could have done is you could have done angles in a straight line as well, where you could have had something, because you had that other 90 degrees. So remember that this part was also 90 degrees. So you could have actually went 180 minus 90 minus 24 to give you that 66 as well. Okay, so grades wise for this question, just giving the answer is going to get you an achieved, and giving an answer with a reason is going to get you a merit. Okay, that's question 1. Okay, so with this question you've been asked to find what angle DGC is. So I'm basically looking at this particular angle here. Now looking at my triangle, I can see that because it has a line of symmetry, and the BCF triangle is going to be similar to CDG triangle, which means this part and this part should be equal, which creates an isosceles triangle. So what I could really say is that angle CGD equals angle CDG. Okay, because they're isosceles triangles. The other thing I can also use is from the previous question. I figured out that angle BCF was 66 degrees. If BCF is equal to 66 degrees, then if it's symmetrical, then I could say angle DCG is also equal to 66 degrees. Okay, so that's this part here, that's 66 degrees. Okay, so now that I've showed that this is an isosceles triangle, I could actually put the reasoning here. I just put this as isosceles triangle. Okay, And I know that angles in a triangle add up to 180, so then I could write this as angle CGD would then equal, well, I've got two of those angles, haven't I? So I've got to go 180 minus 66 and divide it by 2 because I have two isosceles triangles. So which means I get angle CGD equals 57 degrees, and that's because sum of angles of triangles. Okay, so in terms of achieved and merit, I think if you get either the angle, you get an achieved, or CGD calculated, well, or one angle statement. If you get one of those statements right, you get an achieved, but you need to have angle and statement right to get a merit. Okay, next question. All right, so with this question, you've got the height of AE above ground is 1.2 meters. Pippa says the length of KL is 0.53. So she is basically saying that from here to here is 0.53. And then the height above the ground is 1.2. So basically from here to here is 1.2 meters. Now, the triangle that you want to be looking at is this particular triangle here. That's in purple. So I'm just going to sketch it out here. All right, and what we have is we are trying to prove the bottom side, which is KL, and we have C at the top there, which is 1.2 meters CL, and then the angle is 24 degrees. Now, using your SOHCAHTOA, you are trying to figure out what the opposite is. You've been given adjacent, so the rule you're going to be working with is TOA. So in this case, you're going to have tan of 24 degrees equals opposite over adjacent. So tan of 24 degrees is equal to KL divided by adjacent, which is 1.2. And you're going to get 1.2 multiplied by tan 24, which equals to KL. And when you solve this, you should get 0.53 meters as KL. Okay, and that gets you an achieved. All right, next question. All right, so with this one, they're asking you to find the length of CK. Now, CK is actually this length here. All right, so it's basically you're just working with that same triangle that we did in the previous question. All right, so we've got 0.53 at the bottom, 1.2 meters on the top, which is CL. And if you want to figure this out using Pythagoras, so we got CKL, so we can say that CK is equal to square root. Okay, I'll do this the other way. So you can say that hypotenuse squared equals the side squared plus the other side squared. So you're going to get CK squared equals KL squared, which is 0.53 squared, plus 1.2 squared. So CK is equal to square root of 0.53 squared plus 1.2 squared. And what you should get CK as is 1.31 meters. Okay, and this is another achieved question. Okay, next one. Okay, so with this way, there's a couple of ways you can do this question. I'm going to use the similar triangles method here. So what they're saying is that CH, which is from here to here, is 2/3 of CK. Now, we've already figured out what CK is, but well, let's not worry about it. I mean, that's another way you could actually do it. But if CH is actually 2/3 of CK, then you could say that H from H to this point here is also 2/3 of KL. But because we're trying to actually figure out HI, which is the whole thing, we know that from here to here is 0.53, which means according symmetrically, this is on the other side is also going to be 0.53, which means HI is going to be 2/3 of 1.06. Okay, but what we need to do is we need to actually do it with geometric reasoning. So what I'm going to do first is I'm going to put down that KL is equal to 0.53. Therefore, Km equals 2 times 0.53 because this was symmetrical. All right, so I've got Km then equals to 1.06. Now, using similar triangles, I could say that if CH is 2/3 of CK, then I could say that HI is 2/3 of KM because they're similar triangles. Okay, so then I can say 2/3 of KM can be written as 2/3 multiplied by 1.06, and this would give me 0.707 meters. Okay, so basically to get your final answer with all the correct reasoning, you are looking at an excellence. But if you make a relationship between HI and KM, so somewhere around here, you're looking at a merit, HI and KM, a recognition of relationship, recognition of calculation of half HI. So if I'm just looking for the achieved part, it says recognition of relationship between HI and KM. Right, so this is, I mean, with the achieved part, you're kind of making a relationship between HI and KM. But if you give the correct reasoning, oh, okay, so if you give the correct reasoning, you get a merit, but just without the reasoning, you're probably just going to get an achieved. Okay, that's this question. Next one. Okay, so the first thing you need to understand in this question is you've been given a ratio for Mn to Nq. So if I look at Mn, I'm just going to highlight it here. So this is Mn here, from here to here. And that's with A. And then they have NQ, which is with B. So that part there, you can imagine it as A to B. So because these are similar triangles, what I could do with the height as well is if I say that this part here of MT is A, then TR is going to be B. Okay, it's a ratio. I'm not like the ratio when I compare it with A and B. So let's say I'm going to actually deal with the height, just the height of this triangle. So that's MT and then MR. So if I put MT as A, then TR would be B. Okay, so if I calculate this area of the triangle MNP, okay, so I'm going to work out the area of the triangle for MNP. So what I'm going to have is I've got NP and I have the height, which has a ratio of A. So area of this triangle is going to be half times base, which is NP, multiplied by MT. Now I'm going to do the same thing, but this time I'm going to do the same thing for MQS, which is the second triangle. So I've got MQS and I've got R in the middle. Now this particular ratio, just looking at the bottom part is B, while the top part, the ratio is going to be A. So the area in this case is going to be half times the base, which is QS, multiplied by the height, which is MR. So these are my two equations for the area of triangle. And I think this is probably what's going to get you an achieved. But anyway, from here, I'm being asked to compare the area of triangles of MNP and MQS. So I've been asked to compare the area between MNP and MQS. Now the area of MNP, I've already got it at the top here, which is in the blue. That's going to be 0.5 times NP times MT. Then I have the area of MQS, which is going to be 0.5 times QS times MR. So my 2.5s go away, and what I'm left over with is NP times MT divided by QS times MR. The next part I need to have a look at is, because these are all ratios that I'm working with, right? So if I just look at NP, now NP is here, this part here, NP and QS, because they're similar triangles, they should have how do I say it? Because they're similar triangles, what I can write this as, I can say that NP divided by QS should equal to MT divided by MR, because they're similar triangles. But that ratio itself, if you have a look at that ratio itself, that ratio is A is to B. So I could actually replace this with A over B, because that's the ratio of this particular similar triangle. So, not B, sorry, the MR, as you can see, it shouldn't be B, it should actually be A plus B. Because I'm looking at the whole MR, so that's what it's going to be. So if I go back to my actual comparison of areas, I have NP over QS multiplied by MT over MR. Now because this ratio is A over A plus B, I can write this as A over A plus B multiplied by A over A plus B. And this simplifies to A squared over A plus B squared. So that's what you are required to do for a merit. But even if you get up to, say, this part here, you're looking at an achieved, and just comparison of areas of triangles, so just setting it up, you are probably looking at a merit at somewhere around there or there. It looks like a tricky question, but guys, it's just similar triangles and just working with the ratios there. And as long as you understand similar triangles, you should be able to do this question. Okay, so that's us with question 1. Now we move to question 2. Okay, so with question 2, we've got a regular pentagon with center O. Find value of x and explain your answer. Now, we know that x is equal to 360 degrees divided by 5, which it should give us 72 degrees. And the reason we can say that is because sum of exterior angles of any polygon equals 360 degrees. And also the other thing you want to mention is that in this case, because the pentagon is a regular shape, therefore exterior angles are equal. Okay, and that is an achieved question. Okay, next question. Now, there's a couple of ways you can do this question, but the way I'm going to do this question is I'm actually going to figure out angle COD first. So I'm going to work out angle COD first. Now, the way I'm going to do it is, because it's a pentagon, I'm going to split this pentagon up into 5 little triangles. And what I'm noticing is that those 5 angles are actually equal. Okay, so angles at a point is what I'm looking at, and there's 5 angles that add up to 360, which means if I do 360 divided by 5, I'm going to get angle COD, which is 72 degrees. Now this one I can write as angles at a point. So once I've figured out that this is 72 degrees, because it's a regular pentagon, I know that I'm going to be dealing with an isosceles triangle. Okay, so then I could say that angle y, or I could actually just say that angle y is equal to 180 minus 72 degrees divided by 2, because in this case we're looking at base angles of an isosceles triangle, which means I'm going to get an answer of y is equal to 54 degrees. Now it's a good idea to actually mention why this is going to be an isosceles triangle, and you can just say that the distance between center to vertex is always the same. Always the same in a regular polygon. Okay, it's really important that you guys mention why you're doing the things that you are doing. And so in this case, you know, just getting a y value is going to get you an achieved, but the justification and the reasoning is going to get you a merit. Okay, next question. Okay, so with this one, you've been asked to find the angle ACO, which is a terrible diagram, but let's try that again. You're asked to find angle ACO. Now, looking at this, you can straight away see that angle PCO is this one here. So you can say that angle PCO equals 90 degrees because it's tangent at a circle. Which means angle ACO equals angle PCO minus 40 degrees. So you're going to get 90 minus 40, which is 50 degrees. Of course, if you want to mention that they are complementary angles. Okay, so correct angle and correct reason gets you an achieved. Okay, next question. Alright, so with this question you've been asked to find angle OAB. So basically you've been asked to find this little angle here. Alright, so what do we know? We know from the previous question that this little angle here is 50 degrees. So because we have that 50 degrees, which is angle OCA, our next job is to try and figure out what this angle here is. So what we can say then is angle OAC. All right, OAC is basically this blue little angle here. It's going to equal 50 degrees. And the reason it's going to equal 50 degrees is because we know that OAC is actually an isosceles triangle, and that these two sides are the radius of the circle, and therefore it's an isosceles triangle. So we can say that angle OAC is then equal to 50 degrees. So this part here is 50 degrees, and that's because we have base angles which form an isosceles triangle, and base angles are equal because of isosceles triangle with where you have a radius involved in it. Okay, so once we have angle OAC, our next job is to try and figure out what this this yellow angle is. But what we do know is we also can work out angle BAC. Now angle BAC is 90 degrees, and the reasons because it's a semicircle, because angles in a semicircle is equal to 90 degrees. So I'm talking about this particular angle here. That's going to be 90 degrees, and that's because we can say angle in a semicircle. So now that we have angle BAC, then we can say that angle what are we looking for? OAB or BAO, same thing, can be written as angle BAC minus the blue angle, which is angle OAC. So what we end up with is 90 minus 50, and that should give us 40 degrees as our angle. And you can just say, well, that's because they're complementary angles. Cool. So for an answer that's correct with reason, you are looking at a grade of merit. And if you just have one angle statement with reason, then you're looking at an achieved. So perhaps something like one of this, or maybe one of this. Cool. That's it for this question. We move on. Okay, so with this question, we've got a circle, and obviously we have a right angle triangle inside of it. The reason it's right angle triangle is because we have N, L, M, it's in angles in a semicircle. So we know to start off that this here is going to be 90 degrees. Okay, so they tell you that OL is equal to X centimeters. So OL is X centimeters, which is this right here. Then they're letting us know that angle LOM equals 8 degrees. So that's LOM, which means that's 8 degrees. Now they're asking us to calculate the length of NL in terms of X and A. Okay, so you've been asked to figure out what this, let's just make that, it's a straight line right there. So they're asking us to figure out what this is. Don't forget it's a 90-degree angle. Okay, so the first thing you really want to be doing is there's multiple ways in which you can actually approach this particular question. All right, so I'm going to actually figure out what the angle NML is, and I'm going to work it out. So I'm actually going to work out what this angle here is. Okay, so because you have OML is an isosceles triangle, I'm looking at this this particular triangle here, it's going to be an isosceles triangle. So because you have 8 degrees there, I could say that angle OML, okay, that's the orange angle I'm looking at, okay, is equal to 180 minus A divided by 2. Okay, and that's because it's base angles in an isosceles triangle. Okay, so then I have this angle here, which is going to be 180 minus A over 2. Now this next part is the I wouldn't call it the tricky part, but it's just if you understand that X, in this case, X is actually the distance of OL, which means X is also the radius. So if X is the radius, then you can say that ON is also X because that's the radius, and OM is also X because that's the radius. So what you should then have is you should have a right angle triangle that looks like this, where this is NL, that's O right there, which is your center. So you've got your X there and X there. And of course you have this orange angle here, which is OM, well, ML. So let's see, that's going to be OML right there. So, and you're asked to figure out what this distance is here. So I could use SOHCAHTOA for this. So what I'm going to do is, because I have my angle, this side, NL, is going to be the opposite side, and my hypotenuse is going to be H. So I can see that I'm going to be using the sine rule for this. So I'm going to have sine of the orange angle. In this case, it's 180 minus A over 2 equals opposite divided by hypotenuse. And the hypotenuse in this case is x plus x, which is 2x. So opposite, I can write that as NL, and moving the 2x to the other side, I'm going to get 2x sine 180 minus A over 2, and that is what NL is going to equal. So that's NL given in terms of x and A. So correct solution with reasons. You're looking at excellence for this. If you're working towards this answer, or somewhere towards this answer, you're looking at a merit. And one step in calculation with reason. So I guess you could get an achieve just by maybe doing one of these things. Of course, this has many different ways in which you can do this question. So you could pick up grades in different ways as well. So yeah, that's basically how you do this one. All right, let's move on to the next one. All right, guys, so the first angle I'm going to work out in this case is going to be angle SOY. Okay, angle SOY is going to equal 2x because that's angles at a center. Now the next angle I'm going to work out is angle XYZ, which happens to be here. So angle XYZ equals 90 degrees because that's tangent to radius, which means my next one is angle, let's work out this one here, angle OSR. So angle OSR is equal to also 90 degrees because that's with tangent to radius. Okay, so which means I've got 90 here and I've got 90 there, which means the next one I can work out is angle SRY. So angle SRY is equal to, I could put that as 360 minus 90 minus 90 minus 2x. Okay, which means angle SRY equals 180 minus 2x. So that's this angle here. And the reason behind it is because you can have angles that up to 360 in a four-sided shape. Now I'm sure there's a particularly good reason, but I just can't think of it at the moment. So once you have that as 180 minus 2x, then the next angle you could work out is SRZ. Angle SRZ would then equal 2x because 180 minus 2x is going to be positive 2x. So it's angles on a line. So this angle here is 2x. Now for those of you that don't know how I got that 2x, just have a look at this, because I went 180 minus 180 minus 2x, and when I do this, I'm going to end up with 180 minus 180 plus 2x, and that's how I end up with 2x. Okay, so the next angle I want to work out is angle XSO. All right, that's this one here. Now angle XSO is actually x degrees because it's base angles of an isosceles triangle, which means going all the way around, I can figure out what angle RSZ is. So that's this new blue angle, just angle RSZ is 180 minus 90 minus x, because remember that this was also x. So we have angle RSZ equals 90 minus x, and that's because angles on a line. So this here is 90 minus x. So finally I could work out what angle RZS is. I'm sorry guys, I'm running out of space here. I'm going to work out here. Angle RZS is equal to 180 minus 2x minus 90 minus x. Just make sure you put the brackets correctly. So you're going to get 180 minus 2x minus 90 plus x, and this simplifies to 90 minus x. And this is because of angle sum of a triangle. You can just say angles in triangle equal 180 degrees. So you have 90 minus x is this. So once you have this, what you can then see is you can actually see that angle RSZ equals angle RZS. Therefore, this is an isosceles triangle. And if this is an isosceles triangle, then RS equals RZ, because you see how these two are an isosceles triangle. Now, originally, they tell you that RY equals RS, which can be seen right here. So therefore, you can say RY equals RZ. And that's your proof. Now, guys, I'm sorry I went this the long-winded way. I'm sure there's shortcuts that you probably picked up that I missed out on. But yeah, pick whatever works for you. But as long as you prove all the values with the reasoning, you'll be fine. Cool. So basically for excellence, you really need to get to the last part. For merit, you're probably looking at 4 steps, and achieved is probably 2 steps in getting to the solution. Okay, that's it for this question, guys. We move on to the next one. All right, guys, so in this question, you've got a farmer that's using a 3-meter ladder. So that's 3 meters there. The top of the tank is 2.9 from the ground. So that distance is 2.9 meters. He wants the angle of the ladder to be less than 80 degrees. Okay, so we know that that's 2.9, which is the height. And so we need to figure out what this little angle is going to be. So we're going to use SOHCAHTOA for this. So we have, wrong color. Maybe let's try this color. We've got opposite there, and we've got hypotenuse here. So we're going to be using the sine rule. So we have sine of, I'm going to put this as x. Sine of x is opposite over hypotenuse. So sine of x is equal to 2.9 divided by 3, and x is equal to sine of inverse sine of 2.9 over 3. And so we're going to figure out that x is actually equal to 75.2 degrees. Now he wants the angle of the ladder to be less than 80 degrees. So then we can say Yes, the ladder is long enough. Yes, the ladder is long enough. Now, with this question, just a calculation will get you an achieved, and the conclusion is going to get you a merit. Okay, let's go to the next question. So with this one, they're asking you how far is the foot of this ladder from the base of the tank. So we know that that's still 3, and that's 2.9, and they're asking you what is that one going to be there. So because they form a right angle triangle, I'm going to call this one B for base. All right, so I know that base squared plus 2.9 squared equals 3 squared. So then base squared is equal to 3 squared minus 2.9 squared. So b squared equals square root of 3 squared minus 2.9 squared. I should really say b. Therefore, b is equal to 0.77 meters. And that gets you an achieved grade. Okay, go to the next question. All right, guys, so with this question, the farmer is actually placing the ladder at 80 degrees to the ground. So that means this angle here is 80 degrees. Now, how much of the ladder is above the top of the tank? So basically, we know that this is still going to be 2.9 meters. All right, I mean, that's not going to change. Now, the length of the ladder was originally 3 meters. Okay, so what we are trying to figure out is what this distance here is going to be. So using SOHCAHTOA, we have this as the opposite and this as the hypotenuse. Okay, so then we have sine of 80 degrees equals opposite over hypotenuse. And so in this case, h is then equal to opposite divided by sine 80. So h is equal to 2.9 divided by sine 80. So when we do this, we actually get h is equal to 2.94 meters. Now what that means is that the ladder is 3 meters long, right? So that part from there to there is 2.94 meters. So to figure out how much of the ladder is above the top of the tank, you've got to go 3 minus 2.94, which gives you 0.06 meters above the tank. Okay, so in terms of grades, setting up the equation, setting up of equations, I think obviously up to here, you're probably looking at an achieved, just around here. And then solving for x and calculating the difference, you're looking at a merit for this question. All right, let's go to the next one. So with this one, you've got a whole lot of information here, but let's just have a look at what they're actually asking you to find. In this question, they're asking you to find the size of the angle ECB. Now, ECB is this angle here. And if you look at it, you can see that it's actually two parallel lines that are going through. So angle ECB is equal to 108 degrees because they are corresponding angles. And that's pretty much it for this question, which is an achieved question. All right, so let's go to the next one. All right, guys, so for this question here, you've basically got RSTU is a trapezium. They're asking you to determine any geometrical facts about this particular trapezium and then prove that this is all true for all such trapeziums. So the first thing I'm going to do is I'm going to put this angle TUR here as x. Okay, let's say, I mean, that's how it's, I'm putting this as like if angle TUR equals x, then I can say that angle STU equals 180 minus x. Okay, and that's because they are co-interior angles in a parallel lines. On the other end, if I put, so this blue angle here is going to be one light blue angle is 180 minus x. On the other end, I'm going to put URS, which is this angle here, as y. So angle URS equals y. And again, this is one of those if things. If angle URS equals y, then I can say that angle URS, not URS, angle RST, angle RST. Okay, so I've got RST would then equal 180 minus y. Again, this is because they are co-interior angles. Now, this is a quadrilateral inside a circle, which means the opposite angles must add up to 180 degrees. So I'm looking at this angle RST, that's 180 minus y. So basically what we're trying to say is that if it's a cyclic, that this angle, so those two angles that's marked in the pink, must add up to 180 because opposite angles of a cyclic quadrilateral. So if I take those two angles, I have x plus 180 minus y should equal to 180 degrees, and that's because of opposite angles, as I said before, opposite angles in a cyclic quadrilateral. So when I rearrange this, I'm going to get x minus y is equal to 0, which means x is equal to y. So what I've actually proven right now is that if x equals to y, then you're dealing with a trapezium that's actually an isosceles trapezium. So then we can say that RTSU is an isosceles trapezium. Okay, because they have two, the two base angles are the same. The other thing that you could also say is that RTSU is symmetrical. Okay, that's another thing you could say. Now this is going to be true for all trapeziums inside a circle because of that cyclic quadrilateral rule. So you can just say this is true for all trapeziums inside a circle. Okay, so grades wise, this is your generalization there, which is excellence. Recognizing that trapezium is isosceles, it's a merit. And 2 correct statements. So basically, if you do 2 correct statements here, or just one of them with the correct reason, you're probably looking at an achieve there. Cool, that's it for this question, guys. We go to the last one. Alright guys, the best way to do this question is to actually draw a diagram. Now I'm going to try and squeeze this entire question in this one little slide, but let's see how that works. So basically I've got airstrip A, and that's my bearing north at the moment. So the plane is going on a bearing of 310 degrees and it goes for 40 kilometers. So 310 degrees is basically going around 310, and that's, so that right there is 310 bearing, and we know that this is going to be 40. Now from this point, that's B right there. From B it flies 45 kilometers due north to airstrip C. Okay, so it's going north, so that's C, that's 45 kilometers. Then directly, the plane then directly heads directly to airstrip D, which is 135 kilometers due north of its starting point at airstrip A. So because A is here, we can kind of assume that D is obviously somewhere there, and the plane is going like that. Now we know the distance from that point all the way to A is going to be 135 kilometers. So the question says, for the final leg of the flight path, how far does it need to fly, and what's the bearing of the final leg of the flight path? So basically what we're looking for is what's for the final leg, how far does it need to fly. So we're looking for this distance here, all right, from C to D. And the other thing that's been asked to find is what's the bearing of the final stage. So we're looking for that angle there, which let's just put that as maybe not, let's just put that as a little b as bearing. Okay, so our first step here is to figure out, I'm going to split this up into little grids so you can kind of see what this is. So there's one grid there, there's one grid there. The first step I'm going to do is I'm going to figure out what this distance here is. Let's use a different pen here. So I'm going to call this, I'm struggling for a letter here. Let's call this P. Let's call this one Q. Okay, so this is also going to be Q. We know that this distance from here to here is 45. Okay, so, and of course I need to, let's put this as R. Okay, hopefully it kind of makes sense what I'm trying to do here. So I'm going to work out P first. Now to work out P, I'm looking at just a small triangle there where P is that, and then I've got my 2 points, which is basically A and B, where this is 40, and because it's 310 as a bearing, that there is going to be 50 degrees. So I can figure out what P is because I'm using SOHCAHTOA, and I've got hypotenuse and adjacent. So cos 50 equals adjacent over hypotenuse. So cos 50 equals P divided by 40. So I've got P over 40. So then I can say that P is equal to 40 times cos 50. So P equals to 25.71. Okay, so now that I have 25.71 here, I can know what R is, because R is going to be 135 minus 45 minus 25.71. But before I get to that, I also need to figure out what Q is. Okay, so to figure out Q, I'm pretty much using the same triangle. So I've got B and I've got A, where that's 40, and I've got 50 degrees, and then Q is this part. I mean, you can see it from the diagram where Q is. Okay, so doing this, I'm going to use, what should I use? I've got hypotenuse, I've got opposite, so this one is going to be sine, so I've got sine 50 equals opposite over hypotenuse, which means sine 50 equals Q divided by 40, which means Q is equal to 40 times sine 50. So I can say Q is equal to 30.64. Okay, so that 30.64, now I have it as Q, which is there. So I know what R was, because R was actually 135 minus that 45 Ks minus 25.71, which actually gives me 64.29 kilometers. So R equals 64.29, which means now I can figure out what D is, because I can use that next triangle where this is 64.29, this is 30.64, and D is the distance it travels from airport C to airstrip C to airstrip D. So here I could say that D is equal to square root of 64.29 squared plus 30.64 squared. And when you do this, you will get an answer of 71.2 kilometers. Now, that's just figured out what the distance is, but you also need to figure out what the bearing is. So to figure out what the bearing, I've actually said I'd like to do B, but I mean, if you think about it, you could actually just I'm gonna see if I can try and draw another triangle there. So I'm looking at this yellow triangle now. All right, so with the yellow triangle, it just makes solving B a lot more easier. All right, that top part of that yellow triangle is going to be 30.64, and the side part here, which is R, that's going to be 64.29. So now I could use SOHCAHTOA again. So I've got opposite and adjacent. So I've got tan B equals opposite over adjacent. So tan B equals 30.64 over 64.29. And so B is equal to shift inverse tan of 30.64 divided by 64.29, and I get a bearing of 25.48 degrees. Now remember, bearings, there are 3 numbers, so in this case you kind of just mention that the plane is traveling 71.2 kilometers on a bearing of 025 or 026, because you can't really have point. I mean, you could, but like we just keep it as whole numbers in this case. All right, so distance and bearing calculated for the 3rd section of the flight. That's what is going to get you an excellence. If you calculate the bearing or the distance, then you get a merit. So merit is either this or this. Achieved is calculation northerly over, so achieved could be either calculating that or calculating that. Okay, yeah, I know it's a big problem, guys. There's a lot of work to do, and it's quite easy to make silly mistakes, but just be patient and just work through it one step at a time. All right, that's it for this session, guys. Thank you for watching, and good luck with your geometric reasoning exam. If you have any questions, pop it in the comments below, and I'll try my best to get to you before then. All right, that's it for this session then. Thanks for watching.